Good morning, everyone. I'm so glad to be here. This is a wonderful conference. I wanted to talk today about generative AI as sort of the next medium and how we're going to build it together. I wanted to start out first with thinking about the history of technology for media. You know, the Gutenberg press, we attribute that to, the start of print media. We then had images, we had audio, we had video games. Every one of these technologies has created new industries and has opened up new experiences for people. And I think that generative AI is going to be the next medium, the next thing that really changes the way that humans transmit ideas and interact with each other. It has the potential to change the way that we do almost all of our work in the way that, for example, we think about education or agriculture or, basically all of the big things that we do as humans. So that's kind of my thesis, is that we're witnessing the creation of a new form of media. It's far more interactive and far more interesting and useful than any of the things that have come before. We're going to use it to do almost everything. Okay, so if that's the thesis, then what do we learn from that, and what do we need to build? Video games, by some measures, are already the biggest medium. So when I think about a medium that's going to come along, it's going to use generative AI to help us solve problems, be more engaging and more useful. I'm thinking about, what is it about video games that has made them so interesting? And I think it has to do with immersion. It has to do with the way that people interact. And when I think about how are people going to interact with generative AI, and remember this is planetary scale, right? So we've got, let's see, approximately 10 billion people on the planet. And we're all interacting with generative AI in ways that, we're currently interacting with other kinds of media, only it's more compelling and more interesting. How's that going to look? How's it going to feel? What are the kinds of interactions that we're going to have? I think that generative AI is going to be even more immersive than video games, and yet it's going to build on video games. When we think about why is it that people spend so much time in virtual worlds, it's because it's interesting to them. And so the question is, how are we going to build that? I think that it's also important to say that a lot of exciting applications of generative AI are the ones that haven't been invented yet. So books still exist. The printing press came along a long time ago. I still read books, right? I still listen to music. And so a lot of the applications of generative AI are going to be doing things that we haven't even dreamed of yet, that are really, really interesting. And I felt like I got a little bit of a sense of that future when I was interacting with this demo that we built at Nvidia called ACE. It stands for Avatar Cloud Engine, I believe. Basically, there's this guy, and he has a ramen shop, and he's kind of like a non-playable character in a video game, but way smarter, because he's powered by an LLM, and you can talk to him, and he talks back. It's a high-quality rendered environment. It looks pretty good. Powered by DLSS, which I'm going to talk about just briefly in a second. Also, it's being driven by an LLM, and that makes it fun to interact with. When I first talked with this guy, he was telling me about how I needed to do this mission with, I don't know, standard mission in a cyberpunk style game of go to this part of the city and get this widget or something like that. But then I started asking him about his favorite Brandenburg concerto, and he told me that it was number 4. And I was like, well, that's very interesting, because I also like Brandenburg concerto number 4. And it was so far off the rails of what you would normally have in a video game that I actually felt like it wasn't just a script that I was interacting with, but it was an intelligence. It was a person. And when we think about how are we going to deliver the benefits of generative AI to 10 billion people, I think this sort of experience is really important, because I think there's limits to what people can do with traditional apps or text boxes or just chatting. So I feel like this kind of immersion, if generative AI is the next medium, then we need to build user interfaces that that look like the Omniverse, where we have virtual worlds that are totally immersive and totally useful. And so another way of thinking this is that language models, like one of the most interesting applications of language models for me is people, or maybe the other way around, that virtual people are like some of the most useful things that we could build with generative AI. Okay, so I wanted to talk about graphics just for a second, because I do think that it matters. When we're talking about the interface for generative AI, there's going to be a lot of visuals that happen. And one thing that some of you may know, but some of you may not, is that we already have a video generation model that's running on hundreds of millions of systems around the world, generating pixels in 400 video games. And we call it DLSS. It stands for Deep Learning Supersampling. In the video that I just showed, every pixel is generated by AI. But if you think about the ratio of pixels that were generated with traditional graphics to the ratio of actual pixels that we're showing, it was 1 to 8. So that means that we did traditional graphics to generate 1 pixel, and then we used AI to generate 7 pixels, and that made the game. Now, there's actually 400 games that have this technology integrated into it, and when you use this technology, it makes your GPU like 5 times more efficient, because it turns out that using a generative model to learn correlations in a video signal and then to infer them at real time is just much more efficient, because there's a lot of things to learn in a video signal that give it structure so we can see things, and then we can use a generative model to capture that and then make the process much more efficient. But maybe even more exciting, beyond making the graphics rendering process more efficient, is that it also makes it more beautiful. So this week, actually, we released our newest version of DLSS that's doing a thing we call ray reconstruction, and it looks better than native rendering. So these generative models are actually making virtual worlds that look much better than the best things that we knew how to do without AI. And I think, again, why am I talking about graphics? I think, again, if we're talking about what's the medium, generative AI as a medium, how are people going to interact with it? I think this is an important part. Okay, so getting back to the kinds of things that we're going to do, so I'm expecting that generative AI is this medium that's going to transform all of our work. It's going to help us in every kind of field. So education. I don't know if any of you have ever read The Diamond Age by Neil Stephenson, but I love that book. And it's subtitled like A Young Woman's Primer, I think, something like that. But basically the thesis is there's like a book that's basically a computer that every child gets to talk to and learn from. And this book is like assessing where they're at and helping them learn and giving them feedback and answering questions. There's a future of education where teachers are working with generative AI to help their students learn absolutely the most interesting things, help the students learn as good as possible. This is not a future where teachers disappear. We're not going to replace teachers. People are centered in this vision that I'm talking about. But it's a vision where we're unlocking human potential with generative AI. And this vision of like education being assisted by generative AI characters, I think is really compelling to me. We have applications in healthcare, in biology, in agriculture. I asked DALL-E 2, this is a DALL-E 2 image, to build me a robot picking strawberries, because there's a lot of things that we do as humans that we could assist with robots, make them more fun, make them faster. I'm really excited about the human potential that will be unlocked from that. Programming. I think Peter Norvig is going to be talking about programming next. There's clearly a lot to do with how we generate computer programs with generative AI. Writing, marketing, robotics, geosciences, how we understand the world around us, how we design things. We're just getting started, and I'm super excited about the possibilities. One of the things that I think is interesting about generative AI is that it brings us into a post-scarcity economy for a lot of interesting problems. So what do I mean by that? Well, we already kind of have a post-scarcity economy for a lot of things. I love piano music, and I play the piano. Not very great. I'm not a great pianist, but I love playing the piano. I don't do that because there's not enough piano music in the world. There's actually basically infinite recordings of piano music. I could listen to only classical piano music for the rest of my days on Earth and still not listen to it all. And yet, there's still more of it being made every day because it says something about the people making it and the people relating to it. So, when I'm playing the piano, I'm expressing myself as a human. And when I listen to other people play, I'm also expressing myself and my opinions. And, so we already have a post-scarcity economy, and we know it feels different from an economy that's based on like pounds of piano music, right? Like if we had an economy for piano music that was like, we just have a dearth of piano music, we just need somebody to fill the earth with piano music, that economy would change quite a bit if we had a machine that could generate piano music, right? Because it would be like, wow, finally there's not a lack of music. Well, we already have that, right? So there's already infinite piano music essentially, and so when we have a generative AI for piano music, it's not going to really change much. I think the experience, right? Because it's still fundamentally going to be about the people. But I think generative AI is going to transform a lot of other things into that sort of a feeling, and that will make a lot of the discussion about the quality and sort of the cultural reflection of an idea rather than the quantity of it. It doesn't make sense, for example, in education to really focus on write a 10-page research paper if you're using generative AI to write it, because it's very easy to generate 10 pages on any topic with a language model. But what's hard is to generate useful ideas that resonate with the culture, that resonate with other people, that express yourself as a person. That's still hard, but that's really interesting. And so in some ways, I'm hoping that generative AI will make it even more true that the content matters more than the form. All right, so now I'm going to talk a little bit about if we assume all of this is true about generative AI being the medium of the future and solving a lot of problems and helping us move to a post-scarcity economy for ideas, then now we need to think about what are we going to build. And I think that we should be thinking about specific intelligence. General intelligence is really foundational, and it's really important, but it's not sufficient. Maybe you have some friends that are super smart, but maybe that's not enough always. Certainly the case for me. And as a parent, I'm always trying to remind my kids that being smart is a start, but then there's more to do. We use specialization to solve problems, and that's what education's about. And it's not just about education. It's not just about knowing things. It's also about being things and being in places. And I think AI is going to need specialization as well. We're going to need artificial specific intelligence. And I think that happens in three main ways. So there's philosophy, which has to do with alignment, which has to do with the unique values and the unique purpose of a particular AI. And we often, AI researchers, we often think about alignment in terms of a sort of globally shared set of values. But again, we're talking about AI that impacts 10 billion people, right? It's not actually true that there is a universal set of values for 10 billion people. We know this, right? This is central to human culture and history, is that people have different values, and companies have different values. Entities that are creating and deploying AI, they have different ways of thinking about what is good and how things should be deployed. And they have different purposes. They have different reasons for doing things. And so alignment is a thing that should be specialized. Perspective, which has to do with training. So, the way that we solve problems as humans is that we have unique perspectives. When I hire people for my team, although I expect that the people that I'm going to interact with are very intelligent, I don't actually give them an IQ test to join my team. I ask them about their particular perspectives and the things that they think about, and the unique experiences that they're bringing to the table based on their history. Every company is built around a secret. Every company has a secret sauce or a secret way of doing its work. And the world's most important data is its most confidential data, you know? Things like medical records, for example, very valuable data, very secret. And I believe it's generally true that like the more valuable data is, the more confidential it becomes, the more restrictions are around the data itself and how it's used, and that's for good reason. And so what that means is that the perspective matters. The perspective should be specialized. We should make it possible for people to build models that you know, are expressing themselves because they were trained on a different set of data. They have different perspective. And then also, I think the position matters a lot. So it's not just enough to know something. You actually have to do something in order to change the world. And every institution has a different way of doing that, has a different business model, has a different set of customers, a different way of accessing the market. And that matters enormously. You know, being in the right place at the wrong time, for example, often means you don't get to solve a problem. And so you have to be in the right place at the right time with the right specialization in order to actually change the world. So, so how are we going to go about building specialized AI? Well, here's an example of a project we have at Nvidia called Picasso, which is a foundry for generative AI models for visual design. It has text-to-image models. It has text-to-video models. It has text-to-3D models. And what we'd like to do is make it possible for organizations to build their own visual models. And the way that works is they may have a model themselves and they want to optimize it and deploy it on a bunch of computers. We're happy to do that. They may have a large data set and they want to put that into a machine that customizes a model for them and deploys it. Or they may have a small data set that they want to use to fine-tune a model to get something custom. And you know, in any case, we want to create an opportunity for all sorts of different companies at different levels of abstraction with different resources, different perspectives, different positions in the market to create custom AI that helps them solve problems. And just this week, actually, we launched our first collaboration in this space with Getty Images. So Getty Images actually has their own data set, right? All of the images that they've built up over a long period of time. It's a very special data set. It's very unique. It's very high value. Getty Images is going to want to retain the value of all of the work that they've done to create their company around this set of images that they've built. They also want to have a generative AI model because it seems clearly useful for people to be able to compose images for new problems. But again, it's you know, how do we go about building that? And so they're using our Picasso service and training a model solely on their images, which means that the IP is very clear. They own all of the images, and it means that, you know, that there's legal protections for the people using it. It also means that the artists who contributed to the training data for this have a licensing revenue model that works. And so, you know, I think this is a good example of what I mean by specialized AI, right? Getty is using their own unique philosophy, their own perspective, their own position to do something with generative AI that suits their needs. And I think a lot of companies are going to do that. Now, I've been talking about visual generative AI, but of course, language models are really important as well. I think language models are the most important kind of model, just because they're the way that we reason about intelligence. You know, every idea that humans have, we can express in language, so a model that understands language can be used to solve any problem that humans encounter. And so we've built this system called Nemo, which allows organizations to build their own language models and deploy them. And they can do that in different ways, fine-tuning or training their own model, using foundation models from Nvidia, from the community. And then, of course, it's all accelerated and running really fast on big GPU data centers. When we think about customization for LLMs, there's a lot of work to do. There's prompt learning, there's supervised fine-tuning, there's RLHF and other methods that help us steer the output of a model. There's also information retrieval. You know, I think a lot of the ways that many organizations are going to want to build custom language models that incorporate their own particular perspective, their own particular data. It has to do with information retrieval, so that these language models can provide factual answers to important questions. And so this is all part of the way that we're approaching Nemo. We also have built a system called Nemo Guardrails, which is a way of describing boundaries, kind of soft boundaries for how an LLM should work. These could take the form of soft scripts, so not a hard script, not just like a decision tree, but sort of a bunch of different cases. Like if we're talking about this, then this is the next thing. But there could be many of them active at the same time. Things like safety. How do we prevent hallucinations? How do we keep the content of the output safe to use? And then also security. When these things are composed with other tools, such as through LangChain, we'd like to be able to control what happens when those other tools are used. And so, this is all going into Nemo Guardrails, which is an open source project that you can take a look at on GitHub. Okay, so I've talked a lot about applications of generative AI and applications of specializing AI, and why I think that generative AI is going to be the next medium and why it's going to be specialized. I wanted to end by talking about generative AI as the most important compute problem. So in some sense, we're turning computers into intelligence, right? And this means that the compute side of artificial intelligence is extraordinarily important. Generative AI is the world's most important compute problem. And the way that we go about doing that at NVIDIA is not about chips. I know that a lot of people think that NVIDIA is a chip company, but actually almost all the people at NVIDIA are not building chips. What we're doing is optimizing applications, software frameworks, libraries, compilers, drivers, basically the entire stack that's necessary in order to deliver transformational speed-ups on things that really matter, to help researchers and engineers have a time machine that allows them to access the future because they can train models on bigger data sets quicker. And we don't sort of wait for other people to figure out how to do that optimization, because we know that no one can care about optimizing code for our systems more than we do. If we don't care enough about optimizing the code for our systems, it's just never going to happen. And so that's kind of the secret of NVIDIA. And for 30 years, NVIDIA has been saying this loudly, but it's one of these secrets that you can repeat, and sometimes it's hard to hear what it means. But nonetheless, I think it's really important. I did want to talk just a little bit about the evolution of the systems that we've been building, and of course, all of these are the software has to deliver in order for it to matter. But when the deep learning revolution started in 2012, AlexNet was 60 million parameters, and it took 260 petaflops to train, which you could do on a few GPUs for a few days. GPT-3 obviously is 175 billion parameters and 320 zettaflops. So that takes many thousand GPUs for a very long time, weeks or months, 3 years ago when it was trained. So when you think about the kind of scaling that has gone into that, it's rather extraordinary. And these days, we're building these systems out of our Hopper GPU. This is what one looks like. It has a bunch of memories that are packaged with the processor, and then a bunch of power delivery circuits around it. One of these does 4 petaflops per second in 2 to 4 sparse FP8. It has up to 94 gigabytes of memory attached to it, and it's running at 3.5 terabytes per second bandwidth to that memory. We then compose these into a board with 8 of them, and fully connect them using NVLink switches that allow each of the GPUs to talk to every other GPU at 900 gigabytes per second, which is essential when we're talking about training and deploying these models. Being able to connect these systems, these GPUs together to do that is really necessary, because the compute challenge is so enormous. We then package these things up into a system. We call it one giant GPU, because each GPU, each tiny thread, there's there's many millions, there's hundreds of millions of threads running on the system. They can all read and write memory from any of the GPUs in that system natively, just by dereferencing a pointer. And so that makes it feel like one gigantic GPU when you're programming it. We stick that in a box. It's 11 kilowatts and has 32 petaflops per second in sparse FP8. It's a lot of power, but it's even more compute. So this is the most compute efficient thing that the world's ever seen. Then we stick these boxes together with networking. So networking is essential as we're building these systems. We optimize the networking along with all of the software that goes along with these systems in order to make it possible to scale to the very largest models. And then we package these things up into racks, and then they go into what we call a DGX supercomputer, and then many of those get put together to build a modern AI factory. If you think about something artificial, it needs to be built in a factory. Actually, I think those have the same root, actually, having to do with making things. So what does a factory look like for creating intelligence? You put electricity in, intelligence comes out. It looks like this. A lot of systems together, densely networked, running at insanely high speeds, training enormous models on absolutely gargantuan data sets. And this is actually an example of one. I believe this is from Microsoft. So this is what one of the Azure factories looks like. OK, so in conclusion, generative AI, I believe, is the next medium. It's different from video games. It's going to build on video games, but it's different because it's much more immersive and much more useful. The scope of applications for which it will be deployed is much broader than entertainment. Entertainment's going to be part of it, but it's going to help us do work in all sorts of different areas. It's going to help us find a post-scarcity economy in all sorts of new areas, which then is going to allow us to explore ideas more deeply and learn from each other. And I think generative AI will transform today's AI work. I think it's also going to unlock new ideas, new things. We're going to undertake new projects and unlock human potential. I'm very excited about that. In order to do that, NVIDIA, to make this possible, to make this vision possible, NVIDIA is creating technology that enables organizations to create specialized AI in unique ways, like Picasso and Nemo. And then we're designing and building the factories for intelligence, the accelerated data center. And with that, I'll conclude. Thank you.